Hi everyone. Again, because of this pandemic, we are forced to have our classes by this online mode. Okay. So now, but we can't stop. Okay, you have to appear for your board examination. You'll be carrying out your higher studies in top institutes in India, or some of you might be going abroad also. So we have to continue with our studies. Okay. So now, regard to the physics classes, okay, we have taken, we have started this electric charges and field, and we have also started ray optics, okay. But last few classes, some of you might have missed, okay. So I'm starting this topic, electric charges and field, that chapter from the topic of electric field, okay. Now, electric field, when I say electric field, see, this is from NCERT page number 18 and 19. Those things I'm going to discuss, those two pages I'm going to discuss in today's class. Okay, so basically this electric field, when I say field, this field means region. Okay, field means region, area. Okay, and this region belongs to someone. Okay, now who is that someone, we will identify in this lecture. Okay, now suppose you have two charges, capital Q and small q, separated by distance r. Okay, the two charges are separated by distance r. Now, Coulomb's law provides a mean or way to find the force acting between the charges. Okay, so the force between the charges will be, suppose we are not bothered about the sign of the charges, whether the force is attractive or repulsive. For time being, we are concerned about the magnitude of the force. Okay, so force between these two charges will be F is equal to 1 by 4 pi epsilon naught, capital Q small q by r square. So this is the force on each of the two charges. Okay, now, so that means suppose this charge is fixed, and this charge is fixed, and I can definitely say that this charge is experiencing this force. And if this information is given to you that both the charges are positive charges, then obviously this charge will experience a force in this direction, and this will be the magnitude of the force. Okay, so that means this charge, small q charge, when placed at this particular position, it is experiencing this force. Okay, now the scenario is, now I remove this charge. Okay, now I remove this charge. Now if I remove this charge, what happens to this position, or what happens to this surrounding space? Just because the charge is removed, whether that space has lost its property, that property of repulsion. Now if I bring another charge, so now if I bring charge q dash to the same location, now again this charge experiences a force. That means there is something here, there is something in this place, in the surrounding space, which is exerting a force on this charge. Correct? See, this duster, it is on my hand. Now if I push this duster from this position, this is not going to move. It is going to move only when I bring this finger in contact with the duster, and then it will fall. It will move. Okay, so that is one type of force, that is contact force. We are aware of such forces in class 11. We studied those forces in laws of motion, in work energy, power, collision, and all those things we have studied. In class 12, we are going to study about non-contact forces. Non-contact forces. That means here the charge can exert a force on another charge without coming in contact with that charge. Or those things we have studied in Coulomb's law. Okay, now the point here I am trying to stress is, like, see, this space has some feature because of which, if I bring any other charge, if I bring here q dash, q double dash, all the charges are provided, all the charges are positive, all the charges will experience a repulsive force. All the charges will experience a repulsive force. Okay, why they are experiencing a repulsive force? Because of this charge. Because of this charge. So that means this space is influenced by this space, surrounding space is influenced by this charge. This charge is influencing the surrounding space, and in that space of influence, if you bring any other charge, that charge is going to experience a force. The charge is going to experience a force. So see, this field means region. Electric field means a region where electrostatic property can be seen, can be experienced. Okay, so seen means not with this normal eye. Okay, seen means in that field, if you bring any other charge, you will see that the charge moves. Okay, either it moves away or it moves towards, depending upon the nature of the sign of the charge. Okay, but that charge experiences a force. Okay, force is something which is a observable quantity. Force we can observe. Okay, region we cannot see. Region, the charge, that influence region we cannot see. Okay, but we can define it. How to define? How do we define? So suppose this is the spherical region which denotes the region of influence of a charge capital Q. That means in this region, if you bring any other charge, that charge will experience a force. Okay. Now suppose this region has a radius r. It has a radius r. Okay. Now this is not a circle, it is a spherical region. Spherical region. Okay. Now if I place a point charge Q0 on the surface of the sphere. Okay. Now this Q0 will experience a force provided, suppose I'm assuming that both the charges are positive. Okay, so this Q0 will experience a repulsive force. Okay, now that force will be in the radially outward direction. This is a force experienced by Q0. Okay, now this modified space surrounding this charge, surrounding charge Q, is called the electric field of this charge. Okay, because in this region, if I bring any other charge, it is going to experience a force. So this region is the electric field of this charge. So this is producing the electric field. Okay, so I will name this as source charge. Source charge. Why I am naming it as source charge? Because this charge is producing the field. Okay, this charge is producing the field. Presently, we are not aware of the mathematical expression of force or the field. Oh, sorry. Presently, we are not aware of the mathematical expression for electric field. Okay, just we have an idea about electric field as the modified space around a charge in which other charges will experience a force. The force may be attractive or may be repulsive, depending upon the sign of the charges. Okay, but they will experience a force. So here I am bringing charge Q0 near this Q, and I see that, okay, it is experiencing a repulsive force. So I will name this charge as test charge. Test charge. Okay. Why I am calling it as test charge? Because I am using this charge Q0 to test the presence of electric field. Okay. Test the presence of electric field. Test the presence of the sphere of influence, of the region of influence of this charge capital Q. Now this capital Q is at the center of this spherical region. Okay. So this is called test charge. This is called source charge. Now what is the property of this test charge? Test charge has two properties. Okay. One is it is positive charge. One is it is a positive charge. Okay. Positive charge. The other thing is it is very small. It is very small. What do you mean by small? I mean mathematically I write this as Q0 tends to 0. Q0 tends to 0. So this test charge is a very small charge. Okay. Now what is the reason for these two assumptions? What is the reason? See, reason is I am studying about the electric field of which charge? I am studying the electric field of this charge using this charge. So that means if this charge has a very strong electric field, okay, this charge is having a very strong electric field, it will repel this charge. It will not stay at this particular position. So electric field, I am going to study the electric field of capital Q. So if small q has an equally strong electric field, so it will not be possible to detect or study the electric field of capital Q. Okay, because you will be getting a resultant field in that particular region. See, suppose this area, I am want to study the property of this area, this region, which is under the influence of that charge. Here I have a charge, and for that particular charge, this is the region of influence. Okay. Now, if some other charge is also producing the electric field here, so this region will be under the influence of this charge and this charge. So, but I want to study the electric field of a single charge, not two charges. So that is why I am considering that this small q naught is a very small, so that its own electric field is very small. So I am able to independently study the electric field of this capital Q, the source charge. Okay, so that is the reason it is a small charge. And why it is positive? Because I am going to study this concept of electric field from point of view of force. Okay, because I am aware of Coulomb force. So from the concept of Coulomb force, I am going to study about electric field. Okay, now in the expression for Coulomb force, we have this formula: force equal to 1 by 4 pi epsilon naught. Force equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Q1 Q2 by R square. Okay, now here Q1 is capital Q and Q2 is Q naught. Okay, now see, if Q naught has negative sign, Q naught has negative sign, and capital Q is positive, then the product is negative. Capital Q is positive, Q naught is negative, the product becomes negative. Okay, so I don't want to alter the sign of the, see, 1 by 4 pi epsilon naught, it is a positive quantity, 9 to 10.9. R square, again it is a positive quantity. The Q naught, if one quantity is negative, if you multiply, the overall sign of the expression changes. Overall sign of the expression changes. But see, that means, see, if you multiply a quantity with a negative number, the sign changes. But if you multiply a number with a positive number, the sign remains same. Because if that quantity is negative, capital Q is negative, Q naught is positive. You multiply, sign remains negative. If capital Q is positive, Q naught, you multiply with Q naught, again it is positive, provided Q naught is positive. So I don't want to influence the sign of the this quantity force. Okay, so that is why this Q naught is kept positive, because if you multiply positive quantity with any other quantity, the product sign does not changes. If it is previously it was negative, positive into negative is negative. Previously it was positive, positive into positive is positive. So whatever previously the sign was there, it will remain so. So that is the reason I am taking this test charge as a positive charge, and it is a very small charge. Okay, okay. I hope you are able to understand. See, this regarding this positive sign. See, Q, if it is positive, plus Q into Q naught, it is Q naught, minus Q into Q naught, it is minus Q naught, Q naught, that product. So that means if this quantity is positive, here it is positive. If it is negative, it is negative. So this Q naught is not disturbing the sign. This Q naught is not disturbing the sign, provided it is a positive quantity. It is a positive quantity. So that is why I am taking Q naught as a positive charge, and it is having small magnitude, so that it doesn't have its own electric field which influences the electric field produced by the source charge. Okay, so I hope these things are clear. Okay, now so we have idea about test charge, we have idea about source charge, and now we have idea about this force. What is this force? Force magnitude of this force is 1 by 4 pi epsilon naught, provided this is free space, this is vacuum. Okay, 1 by 4 pi epsilon naught Q naught by R square. This is the expression for force. Okay, now electric field, we have defined electric field as the modified space around a charge in which any other charge will experience a force. Okay, that is the surrounding space of a charge. But how to measure the electric field? Electric field is measured in terms of electric field intensity. So electric field and electric field intensity, they are same thing. Okay, so electric field is same as electric field intensity. It is a vector quantity denoted by capital E. It is a vector quantity. Okay, now mathematically, how do you define it? How to measure it? Force we have seen. So basically, electric field It is force experienced per unit test charge. Force experienced per unit test charge. Okay, so test charge, what is the quality of this test charge? Test charge is small. So we write here limit Q naught tends to 0. Limit Q naught tends to 0. What do you mean by Q naught tends to 0? Q naught tends to 0 means test charge is small. Q naught is the test charge and test charge is small. Okay. So this is how mathematically we define electric field. It is defined as force experienced per unit test charge. Now from this I can write F by Q naught is equal to 1 by 4 pi epsilon naught Q by R square, and force experienced per unit charge, force experienced per unit charge per unit test charge is the electric field. So that means this quantity is the electric field. This is the electric field of which charge? Of charge capital Q. Okay, so this is the electric field due to a point charge. Now electric field due to a point charge, it is inversely proportional to R square. So that means as you move away from this charge, the magnitude of electric field intensity decreases. Magnitude of electric field intensity decreases. Okay, as you move away from this charge, the magnitude of electric field intensity decreases. Okay, now one more thing. See here, electric field is force per unit test charge, and what is the sign of the test charge? Test charge is positive. So that means force and electric field, they are in the same direction. Force and electric field, these are vector quantities, they are in the same direction. So that means if force is in the radially outward direction, for this particular charge, for charge capital Q. So that means at this location, electric field will also be in the same direction. Electric field will also be in the same direction, and this electric field belongs to which charge? Capital Q. And what is the sign of the capital Q charge? Positive charge. So that means for a positive charge, electric field intensity at this point will be directed away from the charge. Okay, so this is another important concept. So let me write it over here. So if this is a positive charge at this particular location, you want to find the direction of the electric field intensity. So you have to place a test charge. Test charge is used to detect the electric field, to define the electric field. Okay, so if test charge is, what is the sign of the test charge? Test charge is a positive charge. So if I place test charge over here, test charge will experience an attractive force or repulsive force. Test charge is positive charge, this charge is also positive. Test charge will experience a repulsive force, it will experience a force away from this charge, and direction in which the test charge experiences a force, the electric field is also in the same direction. So that means electric field here, it will be in outward direction. So you can say that electric field intensity at a point, due to positive charge is directed away from the charge. Okay, so electric field at a point due to positive charge is always directed away from the charge, Okay, now similarly, if we have a negative charge, okay, suppose we have a negative charge and we want to find the direction of the electric field. So this is a negative charge, and at this particular point, if you find the direction of the electric field intensity, what you have to do? You have to place a test charge. Now if you place a test charge at this particular location, remember test charge is a positive charge, so that positive charge will experience an attractive force because this is a negative charge, so it will experience a force in this direction. Field and force, they are in the same direction, so that means this is the direction of the force of the field. So electric field intensity at a point due to a negative charge is always directed towards the negative charge. Okay, so these are some important concepts with regard to direction of electric field. Okay, so now we know what is electric field. Electric field is the modified space around a charge in which any other charge will experience a force. Number one. How do you define electric field? Mathematically, we will define as the force experienced per unit test charge. Okay, and electric field due to a positive charge is always directed away from the charge. Electric field due to a negative charge is always directed towards the charge. Okay, so these are the fundamental basic concepts regarding electric field. Okay, I hope these things are clear to you. Okay, now please go through page number 18 and 19 from your NCERT textbook. Okay.